Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on Building Energy Systems and Auditing. We are in the module number 2, where we are discussing about the building energy systems. Today is the third lecture of the this module. So, we will discuss with the electrical machines and appliances system. So, mostly the appliances and the electrical system that used in the building, mostly what we can think of is one is the pump for water supply, and also we will discuss about the two type of vertical transportation systems in the building, elevators and escalator. So, in commonly some of the appliances which commonly used in a particular building are those, and those are the this table again it is available in the NBC. There is another part of the table. So, those are electrical, the illumination and other appliances. So, mostly the this particular rating, wattage rating we can consider whenever we design something or we want to estimate some kind of the energy, electrical energy required for any kind of equipment in a building. Because if you want to see the total the energy scenario, energy requirement of a building in a holistic manner, we have to consider the heat gains and internal the heats and all, and also the these appliances and the instruments which I am going to use for my day to day life. Water supply network is another very important part of the services, and we all know that it required lot of attention and lot of energy, because we have to actually pump the water from a particular storage tank in the underground storage tank to the overhead. So, the flow diagram will be like that. We can take the incoming water from any kind of the incoming source, municipality or the corporation. We can store it initially in a fire tank, and then the overflow water can go to the water supply tank, which is underground. UG stands for the underground. Then we require a booster pump. We may operate booster pumps once in a day, twice in a day, or maybe more than twice in a day if it is required. This booster pump can also take the water from the underground water by some suction pipe. So, sometimes I may require more, my demand is more, the corporation may not supply that much. So, I have to have my own water the sources. So, underground water sources people definitely use. Through the booster pump, the underground water or maybe the storage tank water in the underground can be lifted to a OH water tank, we called the overhead water tank, and from the overhead water tank through the distribution pipe, through the gravity, we send it to the different floors, different points in toilets, in the food plaza, in the kitchens, and some of the other areas where it is required, the water is required. So, this is the typical network. So, these are the some of the photographs. So, in basement one of the building, it is this pump is installed. So, how we will see I mean we have to require some kind of the initial the understanding to estimate the total water requirement. The NBC provide us some recommendation. Again, I am not going to that detail. So, just for a very minimal amount of discussion, I want to say that we have to see those areas also, not only the occupancy, we have to see the, you require some of the water for the main water supply, which easily can be calculated by the NBC provisions. We require something on the kitchen, we require sometimes laundry if your the building is having laundry. If the building is having chiller plant for your the air conditioning plant or so, you require water, it require also for the landscaping. So, we have a supply, we first we store in a underground, then we have a storage in the main storage in the underground, which is not fire, which is for the water supply, and this we have to have a split storage as per the requirement, and we can actually send from the overhead tank or so. So, now my understanding or my area of concern is the energy requirement of this particular water supply, mostly if it is pumping. So, in a building from the municipality water main through a ferrule is a kind of a attachment from the municipality line or the corporation line to a private line. It is a kind of a nozzle kind of a thing. So, ferrule is one of the very important thing that will be provided by the corporation, and it comes to my area, and then we have a water meter, we have some check valves. Finally, that comes down to a underground tank to some pump. I will going to take it to the overhead tank by the rising main. So, this pump I need to operate, and I first want to see that what is my the horsepower or maybe the kilowatt rating of the pump I required for running that. Okay. So, that is one of the important thing, and from the overhead tank it can be supplied to each and every floor. So, let us find out this equation for the pump, and we want to estimate. So, first of all, it is we need to see that how much mass of the water has to be lifted, right. So, the mass of the water can be found out by the volume of the water that I want to lift by into the density of the water, because the volume multiplied by density is nothing but the mass. So, this is one of the very fundamental relationship. Then I want to find out this mass as I mean to say is that what is the rate of mass I am going to send, okay, because it is a flow of a fluid. So, rate of mass is that, so the rate of volume flow multiplied by the density. So, I got the next equation is that Q, this Q is nothing but V per second, sorry, okay, it is not going. So, let me eraser, yeah. So, volume per second. So, it is something like meter cube per second will be my Q. Okay, rate of discharge, flow rate is this meter cube per second multiplied by the density. Density is your some kg per meter cube. So, it gives me kg per second. So, how much kg per second water I am going to send. So, next is this particular power required to lift. So, the energy required to the lift per unit time. So, that will be the, we have one of our very equation for or relation for energy estimation, that is mgh. So, mass into the gravity into the height of the lift. So, mass I already know, which is this q into the rho, the flow rate into the density, g is the gravitational constant, gravitational I mean not gravitational constant, it is the gravitational acceleration, and h is the amount of lift. So, mass into g into the h will definitely be supplied, and that will be give me the power. This is not the energy, this is the power, because if I see this q into this thing, q into rho is your kg per second multiplied by the g is meter per second square. This gives me the force into h. So, this is the energy per second. So, that means it is watt. So, it is the power. So, that we can understand from this equation. So, we have this equation with us. Of course, finally, we divide that by eta. Eta is nothing but the efficiency, because any motor, anything has some kind of efficiency, always it will not going to run with the 100% efficiency. So, we have to decrease that particular thing with some kind of efficiencies or so. So, this is the equation. So, total head how much we have to lift I have to know, and what will be my flow rate or so. So, let us go to another gate examination that was this particular problem was asked in 2016. A pump is installed in a apartment building to lift the water from the ground level to some tank on the top. The tank capacity is 10,000 liter. The total head of the lift is, that is H, 18 meter. Pumping time is 30 minutes. So, I can find out what is the flow rate. Assuming the acceleration due to gravity is 10 meter per second square, and efficiency of the pump is 80. So, I have to find out in kilowatt what will be my requirement, power requirement of the pump. So, it is very easy. So, the capacity I know in liters. So, I have to actually change it to meter cube per second, that is my flow rate. So, this is the liter, I divide that by 1000 because 1000 liter is 1 meter cube, and I divide that by 30 minutes. So, I have to pump it within 30 minutes. So, 30 minutes I transfer to the second, 30 into 60. So, that means 0.0055 meter cube per second will be my flow rate, and the density of the liquid is 1000 kg per meter cube. G is the gravitational acceleration, and all these things ahead and the pump, these things are there. So, I use this equation, and then I got that the pump will be required of almost about the 1 point. So, it will be almost about 1.25 kilowatt, 1.25 kilowatt, and I can also change this to from 2 HP because horsepower, because by dividing that watt by 746 watt is equal to 1 horsepower. So, sometimes we go and actually the pump is rated with the horsepower. So, almost about 1.7 horsepower pump is required if I want to pump that particular water in 30 minutes. So, here there are two type of head or maybe three type of head we will discuss. First one is called suction head. Suction head is the height between the pump and the underground tank, how much is the rising, that how much you are rising from the below the pump. So, that is a suction head. You have to suction pressure you have to introduce, and then that is another head is called the delivery head, which is how much is the from the pump to the overhead tank, that is the delivery. So, total amount of lift which is called the static head is nothing but the suction head plus the delivery head. So, that is this is the two. You have to just arithmetically add how much is the suction head and how much is the delivery head or so. Sometimes the suction head may be 0, we are just lifting from the same level. So, it is 0, but definitely there will be some delivery head. Now, there is another head called the dynamic head, which is actually due to the friction of, and there may be some pipe bends are there, and some losses will be there. So, that also can be found out by this formula K into V square by 2G. V is the velocity of the fluid or the water through the pipe, K is a loss coefficient which will be given to you, and so that way we can also find out the velocity this dynamic head, and we can add the static head and the dynamic head to find out the total head. So, in this particular problem I have given a pump and I want to find out what is the capacity of the pump I required. So, here I have to pump in 30 meter is the overhead tank location, height between the pump and this thing. Pump has to locate located 6 meter above the underground tank. So, this is my suction head, this is my delivery head, and I also have to find out the dynamic head also, because I have given friction coefficients and all those kind of things. So, let us see. First of all, I have found out this 36 meter, this 6 plus 30 is my total static head, and I also find out the velocity of the pump, because I know this is the flow rate, because 18,000 is the liter has to be delivered by I think 40 minute, I think it is 45, not 45 has to be there, I will correct it afterwards. So, this will be my total amount of delivery, and then this is the velocity of the water through the pipe. I divide the flow rate by the area. So, this is the flow rate divided by the area. How I got the area? Because it is given that the diameter of the pipe is 100 mm. So, I have pi into r square. So, 50 mm I have transferred it to the meter. So, I found out the dynamic head is very small with respect to 36, you know. So, dynamic head will be really small. So, sometimes you may calculate, sometimes we actually leave that one. So, just for our academic sake we need to see that, check that one. So, total head is now 36.34 and I use the formula and found out the power is required almost about 2.9 kilowatt. So, let us go to the next, the elevator. Elevator, we all know it is the passenger elevator which actually take care of our vertical transportation. So, there are several factors that depends upon the rating of the elevator. So, it is capacity of the elevator, how many person has to be taken into that, the average weight of the passenger, the acceleration and maximum speed of the elevator, and there are counterbalance weight, and that is also required to be estimate. So, this is a governing formula to find out the power requirement of the elevator, where n is the number of rated passenger, because all we know that elevators are given as a 6 passenger, 8 passenger, 12 passenger like that. So, that is the n. MP is the motor power that comes in a watt, and 75, this particular number 75 stands for the average weight of each people. So, let us take that 175. G is the acceleration due to gravity. S is the recommended speed of the elevator and or rated speed of the elevator. We may sometimes say it is a top speed of the elevator. CF is the counterbalance factor which actually play a kind of a small role in the motor mechanism, and eta is efficiency, it is almost about 85% we can take. So, for this particular problem, it is a very straightforward problem. A 16 passenger elevator, I want to find out how much is the capacity. So, how much is the rated motor power, how much motor I has to install. So, I have values like this is 16, n is 16, 75 is that the weight, G value is, I know everything, I know the value of S is given as 1.6 meter per second is the rated speed, counter weight is 0.4 and efficiency 70% or so. So, by virtue of that I got this value of 16.14 kilowatt will be. So, I have to purchase a motor whatever to run that one, or maybe it will be actually installed with the elevator system itself, which is around 16-20 kilowatt motor. So, that is estimated for a elevator which is taking care of 16 people with almost maximum speed of 1.6 meter per second, which two are very important parameter. Now, for the energy consumption point of view, what we can do is that in case of energy consumption, we have to see that how long it is operating per day, right. So, how much per day it is operating, how much is total stoppage, what is the journey time and all those. So, total energy consumption is the motor power multiplied by the running time. So, motor power comes in kilowatt and running time is hour. So, kilowatt hour I can find out, and total running time I can find out if I want to find out the total running time, total number of stops per day, how much is the stops, and the average trip time between that stops or number of starts per day, and those kind of the start means from one level it stops over here, again it starts, so number of start and the average trip time between this start. So, suppose there are 3 starts, so there are 2 such trip time or whatever. So, that way you can find out the total amount of run, total amount of hours of run, and with this particular formula the motor power multiply the start, total start and trip time, average trip time we can find out, and by some kind of average method or maybe some kind of a survey, and then I can find out the total power estimation. So, in another problem I have calculated that one. So, the power is average power is of the motor is 45 kilowatt, and it has estimated as 2 peak. So, for 2 hours of peak time it has 240 start per hour, and other 6 hours non peak time. So, 6 plus 2 plus 2 total 10 hours of operation. So, our other 6 hours this activity is the stoppage or the start is almost 40 start per hour, and we have also estimated 10 such starts takes about 75 seconds in average. So, we have to find out. So, first of all I have this formula, the MP value is 45, total start per day is 1200, because for 2 peak hours, for 2 hours per hour 240 and 6 non peak hour per hour 40. So, 1200 starts per day. And now I want to find out the what is the trip time between the starts. So, I have a data that 75 second is average time taken for 10 such start. So, I can find out the average trip time like 75 by 9, because why 9? Because if there are 10 such start, there are 9 such trips, 1 minus, right. So, 8.33 seconds is the average trip time between 2 start, right. So, this is now very easily I can calculate. So, total this much amount of running time in second, because 8.33 is in second multiplied by 1200 is in how many starts. So, this is also second, total this much amount of second is the running time divided by 3600, so total hour and multiplied by 40. So, that way I can find out that it is almost for 750 kilowatt hour is my energy requirement for this particular lift to run for a day. Next, let us go to the escalator, another the electrical equipment which we use in the building, particularly in the mall, in the airport, in the railway stations. So, to again two part I want to see that how to find out this motor capacity and estimate the motor capacity, and from the motor capacity how can I find out the number of the kilowatt hour used for particular day. So, for the escalator also there are some parameter we need to know, the how much is the vertical height it will actually going to cover, what is the efficiency of all the motor box, what is the running speed, the angle of inclination, if it is stiffer or it is gentle. So, based on that it will going to change, the power requirement will be changed, even I have to know the rise of the each steps or so. So, in that way I can actually find out the total number of passenger weight and multiplied by some the angular ways or the inclined way of disbursement or the displacement. So, if I want to find out the maximum weight of a person, not person, maximum weight of the person in a particular escalator, I am assuming that the whole escalator from the ground to the top is full of people. Sometimes it happened in the airport, sometimes it happened in the railway station. So, it is full, because in the busy time when there is a train arrived or maybe 2-3 plane arrives suddenly. So, there is a crowd. So, that will be the maximum. So, how I will going to each passenger, weight of each passenger, number of passenger in each step and number of steps in a particular, suppose you take a screenshot of a escalator. So, there are suppose 18 steps and each steps there are 5 people. So, there are 90 people, because 18 into 9 people per this thing. So, you can find out. So, like that I can first find out the number of steps. Number of steps are the RE divided by the RS. What is RE? RE is the vertical distance from ground to the top of the escalator, that is RE. And what is RS? RS is the one vertical step riser of the how much is the riser. Okay, so, that will give you number of steps, and I will find out number of passenger in per step per that particular step. It may be 3, it may be 5, it may be 2. If it is very narrow 2, sometimes it is in case of the metro stations and all, we may say it is 3, 4, maximum 3, 4 or something like that. In case of the railway station, sometimes it is large. So, anyway, so whatever may be the cases, we have to see that how much passenger can be stand in a particular row. So, the mass of one person, then the mass into gravity is your weight divided by the number of person n. What is n? N is the number of person per step. It may be 1, maybe sometimes 1.5, that may be some steps it is little too able bodied person, one is 1 in through the 3 children, something like that. So, sometimes we may say it is average 1.5, and this is the number of steps. So, this way I can find out the amount of weight, the total passenger weight. Now, we have to go back to our class 12 physics. This weight is on a inclined plane, and this things is moving. So, if this weight is moving in an angle theta, so you have to counterbalance this w sin theta, this component w sin, because this is theta, this is theta. So, if this is theta, then this is cos w cos theta, and this is w sin theta. So, w sin theta component is a force multiplied by the speed, this is s is the speed. So, that will give you, so what is force is Newton, what is speed meter per second. So, what is this Newton meter is energy, that is joule per second. So, that is your watt, right, and eta is the efficiency, it is unitless. So, I can easily find out the motor power. So, I need to know how much is the inclination, is it 30 degree, is it 60 degree, is it 45 degree, or it is very gentle 20 degree, 25 degree or so, and the average speed is almost like 0.5 to 0.75. So, let us do a problem. The motor is used to drive escalator of rise of 12 meters. So, your 12 meter is the rise, the running speed is 0.75, angle of inclination is 30 degree to the horizontal, and the vertical riser of the steps are 200 mm, okay, 200 mm, almost 8 inch. Assume 3 passenger per step, and the weight of the passenger is 75 kg, considering 80% efficiency. So, first of all, let us find out the what is the total amount of weight of the people. So, in that I have used this equation, the 75 is the weight of one person, this is your g, this is what is 3? 3 is the small n. What is the small n? The number of passenger per step, 3, and this 12 meter is the total vertical distance between the ground to the top of the particular escalator, which is having 30 degree inclination, but each steps are having 0.2 meter, 200 mm. So, total number of steps is 12 divided by 0.2. So, if I multiply, I will get this much kilonewton as the weight of the, I think it is not kilonewton, again I will rectify that one, it will be in Newton. That much Newton will be the total amount of load, total amount of the weight of the passenger in that particular escalator when it is running full, and I multiply the sin theta multiplied with 0.75. What is 0.75 is the velocity, the maximum running speed divided by 0.8 the efficiency. So, I have to actually think for a motor for this escalator, 62.1 kilowatt motor to run this particular system for the this 80% efficiency with fullest amount of load. Now, how can I find out the energy consumption per day? Again, we have to see some of the things, that the rating of this motor and this particular mechanical design efficiency, the landing levels and the travel times and stoppage times and all. So, this is the equation. So, where I can just have multiplied this particular energy equations, which I have derived little early, with this T, where this T is your total time or efficiency in hours, I mean total time of the operation per day. So, we have to estimate that one, how much hours it is operating, and S is S sin theta, G, N, all these things are your as we have discussed earlier, what is n? Total number of passenger using the escalator per day. So, all these things are there. So, what I have found out here, I mean try to give in an example, a shopping mall, the average 8 hours per day will be the work. The angle of inclination is again 30 degree, and with the horizontal the rated running speed 0.75, same I have kept. Estimated footfall of the escalator is 900 per day. So, that is your this n, this n is your now 900. Estimated footfall per day of the shopping mall is 900, that you need to survey, you need to estimate, and average mass of the each passenger I have kept as 60 kg, 30 degrees inclination, this is the rated speed, 8 hours of operation. So, all these things if I put over here, then I found out that per day it will be 1986.5 kilowatt hour will be the power demand or energy requirement of the particular escalator. So, that is all for this today's lecture, and these are the references. So, what we understand today is that the appliances load which comes from the some BIS code of NBC, or sometimes we prescribe for some kind of brochure of the equipment brochure also gives that. We also discuss about the pump, elevators and escalators energy requirement today. So, thank you very much.